All right, now we're reviewing for the topic test. So the first thing you're going to do is work on some fluency review. Fluency practice is your ability to just do the computation without word problems. So practice some fluency, and when you're finished that, you're going to take a look at the vocabulary review. For the vocabulary review, for each of these terms, give an example and a non-example. So something that is the power of 10. I could say 1,000 is the power of 10. It would be 10 to the third power. A non-example would be any random number that doesn't begin with a 1 and end in a 0. So I could put the number 4, 5, whatever. Multiples of 10 squared. So a multiple of 10 squared, and 10 squared equals 10 times 10, which equals 100. So give me a multiple of 100. 200, 300, 400, 500, 600. A non-example would be a not 100 number. 9 is not a 100 number. An expression with a variable. A variable is a letter. So 6 plus n is a variable. 6 plus 4 is not a variable. There's no letters in there. An underestimate of 532 times 11, underestimating, I'm going to round that down to the largest place value. And maybe I'll leave 11 alone. That's using my compatible numbers. Solve a simpler problem. 5 times 11 is 55. Bring over my 2 zeros. So that would be an underestimate because I brought one value down. A non-example could be if I overestimated. So just say I said I brought that up to 600 times 11 and said 6,600. That would be an overestimate. Sometimes you do want to overestimate because you might be, especially when you're dealing with money, you want to make sure you have enough money. Or if you're baking or if you're cooking, you want to make sure you have enough of something, so you might get a little extra. The sum of partial products is equal to the final product. And these are kind of tricky. Always, sometimes, or never. The sum of a partial product is equal to the final product. Sum means adding. If you add the partial products, is that the same as the final product? It's always the same. And if it's not the same, then you made an error, either in your partial products or in your adding them up. A multiple of a number is the power of the number. Well, sometimes that works, not always. An underestimate results from rounding each factor to a greater number. No, never. It would be a lesser number. And a power of a number is a multiple of the number, always. So it's an opposite of this guy here. So the multiple of a number is the power of the number? No, the power of the number is the multiple of the number. So that was just like a word reversal there. Those are tricky. Okay, moving down a little bit here. Right, true, or false. The partial products for 34 times 321 are 9,630 and 1,284. So we're going to multiply them. And at this point, we are reviewing. You want to be able to know that you understand how to do the process of multiplication without a calculator. So it is a good idea for you to do this stuff without a calculator and check it on a calculator. Don't forget to annex your 0, so you're moving your value over a little bit. Let's see, 321 times 34, what I do? Yeah, so are those right? Yeah, the partial products are right. So that's true, I don't even have to add it. The partial products of 49 times 601 . Okay, that one's good. Let's check my second one. And that one's wrong because there needs to be a 0 at the end there. So that is a false. 642 times 12, 642 tens plus 1,284 ones. And that is true because when your final answer is going to be 642 times 10 plus 642 times 2. So that is a true one. 642 times 2, if you're not sure what that is, you can multiply it. I know I kind of did that in my head. I'm sorry, jumping ahead there. Yeah. And 41 times 10 to the 6th power. Solve a simpler problem, 41 times 1, and then you've got 6 zeros. Is that 6 zeros? Yep. 80 times 10 to the 3rd power. If you do 80 times 10 to the 3rd power is 1,000. So I want 80,000 and I have 8,000. So that is false. Careful on your zeros there. Suppose both factors in a multiplication problem are multiples of 10. Explain why the number of zeros in the product may be different than the total number of zeros in the factors. Include an example. Well, anytime you have, when I always say solve a simpler problem, you have to be careful. So 4 times 5 is 20. And then we're going to annex 1, 2, 3 zeros. So we actually have 4 zeros in our answer. We don't have 3 zeros in our answer. So be careful because when you are multiplying your digits here, 4 times 5 is 20. You're getting a 0 in that answer, and then you're bringing your 3 zeros over. So be careful. Some kids trip up on that one. Like 2 times 5 is 10. There's no zeros in 2 or 5. Let me show you that. 2 times 5, are there any zeros in there? No. But 2 times 5 is 10, so you're going to wind up with a 0 in your answer. So if you have 20 times 500, you're not going to have 3 zeros. You're going to have 4 zeros because 2 times 5 is 10. And then we're going to bring 3 zeros over, so we have a total of 4 zeros. All right. Get rid of that. Now, moving on, we are going to go into the review, the topic review, reteach. So remember, you can go back to these sections in the book if you're having any trouble with any of this, and it looks like Chinese to you or some unknown language. 65 times 10 to the 3rd. First, we're going to figure out what 10 to the 3rd means. And remember, it means 10 times 10 times 10, which is 1,000. So remember to look at the number of zeros for the exponents for the power of 10. So solve a simpler problem. 12 times 1 is 12, and the exponent will tell me, and then I need to put 4 zeros on that problem. 100 times 815, I can take the 815 and put 2 zeros on there. That will be 815 times 100. 39, and then 2 zeros. And this is just 6, 4, 7, 1, and 1 0. It's telling me 1 0. It means times 10. So 10 to the 1st power is the same as just saying 10. 10 to the 0 power is a 1. That one's a little weird. 3 times 10 to the 5th power is a 3 and 5 zeros. And of course, none of these are the tricky ones. Like, 40 times 50. 2 times 1 is 2, and I have 1, 2, 3, 4 zeros. And moving on to set B, you're going to round and estimate here. And it says round the factors or use compatible numbers. Remember, our goal is to get as close as we can to the actual answer when we round. So sometimes we're going to round to the largest place value. Sometimes we're going to be looking for compatible numbers. For instance, on number 1, 7, you could round it up to 10, but I would suggest you try to leave one of the factors alone if you can. It will help you get closer to the actual number. So for number 1, I would leave 7 alone and round 396 up to the greatest place value. So now we have 7 times 400. Solve a simpler problem. 7 times 4 is 28. Bring over those 2 zeros. Number 2, 17 times 63. Now, if you try to leave one of those alone, you could, or you could round both of these because it's not as easy to do in your head. You could do 17 times 60, but that's kind of tricky to do in your head. Or you could make this 20 times 63. So I think we're going to go with 20 times 60. We're going to round both of them. I rounded this one up and that one down. That's a good way to get close to the actual answer. Rounding one value up and one value down. Number 3, and on that one too, there's other ways you could do this. You could do 20, let's see, what else could you do on this one? Whoops. Oh my goodness. Back up, Mrs. Brennan. Bad, Mrs. Brennan. Yeah, teachers make mistakes too. It's late in the day. Actually, it's not even the day. It's into the night. 2 times 6 is 12. Duh. And 2 zeros. All right. If I make more mistakes, I'm going to be stopping this because I'm getting tired here. Number 3, 90 and 91 are pretty close together. And I think I'll bring that to 50 because that's pretty close. Solve a simpler problem. 9 times 5 is 45 and bring over my 2 zeros. Obviously on number 4, you can leave the 70 alone because that's got a nice round number, 7. And 523, we could bring to 500. So we'd have 7 times 5 is 35. And then I'm going to annex my 3 zeros. So 35,000. For number 5, I have 256 times 16. Now, if I round up 256 times 30, or to 300, that is going to be rounding it up a lot. So I know I'm going to have an overestimate on this one, which is fine. But I might try, let's see, what do I want to do with this one? Maybe I will try compatible numbers with this one, because I would be really rounding that up a lot. How about if I round that down to 250 and maybe bring 16 up to 20? So now I have 25 times 2 is 50, and bring my 2 zeros over, 5,000. That would get me closer than if I went 3,000 times 20. That would be a closer to the best answer. I know we're still struggling with that, but we'll get there. Number 6, 45 times 806. So 45 times 800, I don't know if we can do 45 times 8 in our head. How about if we try 50 times 800 for that one? 5 times 8, you can use your multiplication chart. Remember, if you have one, you can use one. There's one in the planner. You can print one off the internet. There's one in your planner from last year if you still have it. 5 times 8 is 40, and we're going to have 1, 2, 3 zeros. And this is another example of one of those problems where you have more zeros in your answer than you do in your problem, because 5 times 8 is 40. And number 7, 27 times 89, I'll bring that up to 30. It's pretty close. And bring that up to 90. I will have an overestimate on here because both of these values are a little bit larger than the actual numbers. And number 8, I'm going to leave that 8 alone. And then for 415, I could bring that to 400. So I'm going to bring it down a little bit. And 8 times 4 is 32, and bring my 2 zeros over. Okay, that was set B. And sorry about the little error over there. Oh, teachers are human. I make spelling errors too sometimes, Okay. For set C, Remember to regroup if necessary, and estimate to check that your answer is reasonable. So in set C, we're actually just solving the problems. So you want to make sure you have this set up nicely on a piece of paper. Remember, you can turn your paper sideways to help you use the columns that are already on the paper to make sure things are nicely lined up. 54 times 9. 9 times 4 is 36. 9 times 5 is 45, plus 3 is 48. So that would be number 1. Number 2, 76 times 59. So we have 9 times 6 is 54. Carry the 5. 9 times 7 is 63, plus 5 is 68. 5 times 6, which is actually a 50. So 50 times 6, 5 times 6 is 30. So I'm going to put my 0 down and carry the 3. 5 times 7 is 35, plus 3, 38. And 5 times, 38. There we go. My problem was done. A little messy, but it's done. And 4484, number 3. See if I can jam this in here. 302 times 47. Maybe if I change my color, that would be a little better for you. 4 times 7 is 14. Put the 4 down, carry the 1. 4 times 0 is 0, plus 1. 4 times 7 is 21. 4 times 2, don't forget to annex your 0. 4 times 2 is 8. 4 times 0 is 0. 4 times 3 is 12. Got your partial products. Add them up. $14,194. Number 4, 871 times 32. 2 times 1 is 2. 2 times 7 is 14. 2 times 8 is 16, plus 1 is 17. 3 times 1, don't forget to annex your 0, is 3. 3 times 7 is 21. Put the 1 down, carry the 2. 3 times 8 is 24, plus 2 is 26. Add them up. Remember, check your work on a calculator. 27,000, so let me check, I'm checking my work. 27,872, yep. Number 5, maybe I can do this one here. 604 times 55. 5 times 4 is 20, carry the 2. 5 times 0 is 0, plus 2. 5 times 6 is 30. 5 times 4, annex my 0. 5 times 4 is 20, carry the 2. 5 times 0 is 0, plus 2. And 5 times 6 is 30. And you notice that's the same value as we have on the first partial product. It's just shifted over one place value. Because we're doing 604 times 5 and 604 times 50. So the same value is going to be in each partial product. It's just shifted over one on the bottom because it was really a 50. Okay, 7,133 times 4. 3 times 4 is 12. Carry the 1. 4 times 3 is 12, plus 1 is 13. Carry the 1. 4 times 1 is 4, plus 1 is 5. And 4 times 3, or 4 times 7 is 28. And don't forget I've been negligent with my commas. Make sure you get your commas in there. It's easier for people to read. Again, it's just a lot of math. If you don't know your math facts, this is this is like holding you up a little bit. And if you're making careless errors in your carrying, you might see some mistakes there. Check everything on the computer. Check the calculator. Check the partial products. Get in the habit of checking partial products, not just checking your answers. Check your partial products, especially as you're learning how to do this. Because a lot of times you might make an error in a partial product. It's good for you to see where your errors are. Instead of just crossing out the answer and writing the right one in from the calculator, you want to learn from your mistakes. All right, we'll get through these next two sections pretty quickly. We're writing an equation with a variable to model each exercise and draw a picture to help if needed. So Alexandria has a collection of 34 dolls. A toy store has 15 times as many dolls. How many dolls are in the store? So it's 34 times 15 equals some random number of dolls. And what is my answer? 34 times 15. 5 times 4 is 20. The 0 down, carry the 2. 5 times 3 is 15, plus 2 is 17. 1 times 4, which is actually 10 times 4, is 4. And 1 times 3 is 3. Add them up. So our dolls equal 510. And if you made a bar diagram, you would say, I don't know what my dolls are, but I know I have 34 times 15, which would be super annoying to make 34 little blocks 15 times. So sometimes people go like this, 15 times, just to show you, 34 is repeating over and over again. But that one doesn't really lend itself very well to a drawing, because you'd have to make a ton of little boxes there, and that would be kind of silly. So because it says you can use a picture to help you if you want, but you don't have to. Number 2, a store received a shipment of 37 TVs valued at $625 each. What is the total value of the shipment? So we're having 625 times 37 equals whatever our shipment total is. So we're doing 625. This is number 1. This is number 2. Times 37. 7 times 5 is 35. 7 times 2 is 14 plus 3. 7 times 6 is 42 plus 1. 3 times 5 is 15. Don't forget your 0. 3 times 2 is 6 plus 1 is 7. 3 times 6 is 18. 5, 12, 11. So we have 23,125 is our shipment. And then on the last one here, Jessica saved $1,250 last year. Courtney saved 7 times as much. This is one you could do the bar diagram on. So we want to know how much money did Courtney save last year. Jessica saved $1,250, as I jam that in there. And we want to draw that 7 times, if you felt like doing that. I don't think actually any of these are really good with the bar diagram because they're too long. So 1,250 times 7 is how we're solving this. 7 times 0 is 0. 7 times 5 is 35. Put the 5 down, carry the 3. 7 times 2 is 14 plus 3. And 7 times 1 is 7 plus 1 is 8. So we've got, the equation would be 1,250 times 7 equals Courtney, or something like that. And then our answer would be Courtney equals 8,750. If you're jamming all that in there. But it's better to put it in a notebook. They do not give you enough room in these workbooks to actually show your work. So I'm not quite sure why. Some problems you can, but some problems are just not enough room. Okay, I'm erasing. It's taking forever. All right, move down. And the last question right here. So remember, on this last lesson, which was a little tricky for some of you, you're looking at somebody else's work and trying to see what they did wrong. We all like to point out each other's mistakes. I know it's like human nature. So let's see what we got here. So remember, you need to carefully consider all parts of an argument. Sarah teaches craft lessons. She has 214 bags of beads. Each bag has enough beads for 22 bracelets. She estimates that since 200 times 20 is 4,000, there are enough beads for 4,000 bracelets. tell how you can critique Sarah's reasoning. So let's take a look at her estimate. So I'm going to examine her estimate is how I'm going to look at her reasoning, examine her math. And does her argument make sense? Well, we're going to do it ourselves and see what we come up with. So 214 times 22. We want to figure out how many bracelets we can make. Do you want an over or an underestimate for this? I would probably want an underestimate for this, not an overestimate. Or let's see, I don't know. What would you want for this one? I would say, let's see what we got. So if she had 200 bags times 22, I would say she has 4,400. She said 200 times 20 is 4,000. I'm losing my pen here. It's acting weird. So does her argument make sense? Well, yeah, it does make sense. She multiplied the numbers correctly. She found an underestimate. It's less than the actual amount. So she can conclude that there are at least enough for 4,000 bracelets. So yes, she has enough for at least 4,000 bracelets. That does make sense. All right, that was it. That was our review of the reteach, and you can watch the video of the practice test, and we'll move on. Take care.